Welcome back to the deep dive. You've brought us a really interesting set of sources today, all digging into tweaking Tamiya's G6-01 chassis. We're talking King Yellow, Kong Head, that whole six-wheel drive platform.
Yeah, it's a fun one. The G6-01, it's kind of legendary for being, well, different. Fully gear-driven, climbs like a goat right out of the box, 40-degree slopes, no problem. It's just pure fun factor.
But like a lot of Tamiya kits, there's room to, let's say, enhance the performance. And our mission here, based on these sources, isn't just about jamming the biggest, fastest motor in there. That sounds like a recipe for disaster.
Oh, absolutely. Broken parts, frustration.
Yeah.
Yeah, the goal is what the sources are calling system synergy. You want balance, durability, reliable power that actually makes the truck better, not just faster for 5 minutes before something breaks.
Right. And it seems like that whole system, that synergy, it starts with one maybe surprisingly small component.
What?
Before you even think about a bigger motor.
You have to tackle the pinion gear. It's the absolute first step. The sources are emphatic. Skipping this is basically asking for immediate failure.
Okay, let's dig into that. The pinion gear. Why is this little piece the absolute foundation for any power upgrade on this chassis?
Well, think about it. It's the very first point where power transfers from the motor shaft into that complex, heavy six-wheel gear train. The stock one, it's soft, like really soft. Aluminum, maybe pot metal. It just cannot take the twisting force, the torque of an upgraded motor.
And there's a huge trap here, isn't there? A technical detail that can wreck things instantly if you get it wrong. The gear pitch.
Yes. This is critical to me if the G6-01 uses a metric gear standard, 0.6 module, often written as mod 0.6.
Okay, 0.6 module, why is that so important to know?
Because the most common standard you find, especially in like American RC brands, is 48 pitch or 48P. And the crucial thing is 0.6 mod and 48P are completely, totally incompatible.
They might look kind of similar if you just glance at them.
They might, to the untrained eye, but the tooth shape, the profile, the spacing, it's all different. Try to mesh a 48P pinion with the G6-01's mod 0.6 spur gear, and you get, well, disaster.
What happens? What does it sound like?
The sources describe it perfectly. A loud and unhealthy grinding noise. The teeth barely engage or engage improperly, and because the pinion is usually metal and the spur is plastic, poof, you rapidly destroy the teeth on the spur gear.
So you're not just ruining the cheap pinion, you're potentially wrecking the main spur gear, which might be harder to replace.
Exactly. So
Yeah.
rule number one, the upgrade pinion must be 0.6 module. No exceptions. But there's a fascinating bit of engineering about that stock, soft pinion.
Oh, yes, the sources mention this. It's soft on purpose.
Precisely. Tamiya designed it that way deliberately. It acts as a mechanical fuse.
A mechanical fuse. How does that work?
Think about it. If the wheels get jammed hard, or if something binds up in that complex drivetrain, all that force gets transmitted back to the motor and pinion. If the pinion was hardened steel from the start,
That force would go deeper into the gearbox, potentially breaking expensive internal plastic gears.
you got it. So the soft pinion sacrifices itself. Its teeth strip before catastrophic damage occurs deeper inside. That's actually pretty clever design for a stock kit.
Clever, but not suitable for upgrades. Once you put in a motor with real torque.
That fuse will blow constantly. It becomes the immediate weak link. So the non-negotiable upgrade is a hardened steel pinion, specifically. Hardened steel, 0.6 mod, 18 tooth, that's the stock gearing size, 18T, and crucially, it needs a 3.175 millimeter bore. That's the standard 18-inch shaft size for most 540 and 550 motors.
Okay, so 0.6 mod, 18T, hardened steel, 3.175 millimeter bore. Got it. The sources mention the Corolali 71618 as a proven example.
That's one confirmed part number, yep.
So if we've replaced this fuse with hardened steel, where does the stress go now if something binds up badly? What's the next likely failure point?
Good question. The stress now gets passed further down the line. Likely culprits become the plastic gears inside the differentials or potentially the drive shafts, which is why, driving style still matters and maybe considering other driveline upgrades later if you push it really hard. But for this stage, the hardened pinion is key.
All right, foundation secured. Now for the heart of the upgrade. The 550 motor, it looks pretty similar to the stock 540, just a bit longer.
Yeah, that's the main physical difference. Same diameter, same mounting screw pattern, 25 millimeter spacing, so it bolts right in. But the can, the main body of the motor, is longer, around 57 millimeters versus about 50 for a standard 540.
And that extra 7 millimeters makes that big a difference.
It really does, for two key reasons. Inside that longer can, you have space for a longer armature, that's the rotating part with the wires, and usually larger or stronger magnets.
And longer armature, bigger magnets. That translates directly to
Torque, more rotational force. The G6-01 is a heavy beast, 6 wheels, lots of gears. There's significant mechanical drag and inertia to overcome.
Yeah.
That extra torque from the 550 is what gives it the punch, the acceleration, the ability to climb and push through stuff where the stock 540 just kind of struggles.
Makes sense. And the second reason?
Heat management. The larger surface area of the 550 can acts like a bigger heat sink.
Ah, so it runs cooler.
Generally, yes, especially under load. When you're working a motor hard, like in this heavy truck, heat builds up fast. Too much heat kills performance and eventually kills the motor. The 550's larger size helps it stay cooler, which means more consistent power and, importantly, a longer lifespan for the motor itself.
Okay, that makes a lot of sense. Now let's quickly tackle the motor turns thing. You see motors listed as 12T, 19T, 27T. What does that actually mean for performance in simple terms?
Right, the T stands for turns. It's about how many times the wire is wrapped around each pole of the armature in a brushed motor. It's kind of an inverse relationship, which can be confusing.
Inverse how?
Lower turns, like say a 12T motor, generally means higher RPM, more potential top speed, but often less low-end torque. It also draws more current, generates more heat. Think of it like the highest gear on a bicycle. Fast on the flats, but harder to get going or climb hills.
Okay, so low turns equals fast, maybe hot, less grunt.
Pretty much. Then higher turns, like a 27T motor, means lower RPM, less top speed but smoother acceleration, more low-end torque, and usually runs cooler and more efficiently. That's like the low gears on your bike. Great for climbing, easy starts, precise control, but you won't win any drag races.
Got it. And the sources are warning that for this specific chassis, the G6-01, you can't just go for the lowest turn motor possible.
Right. There's what the community calls a Goldilocks zone. Go too low turn, like maybe under 12T, and the sheer power and speed could just overwhelm the drivetrain, breaking parts.
Right.
But also because the G6-01 has so much inherent drag.
All those gears and 6 wheels.
Exactly. If you put in a really fast brushed motor, one designed for a lighter, more efficient 2WD buggy maybe, you can actually overload it. The motor struggles against the drag, draws way too much current, overheats, and burns out prematurely.
So the goal isn't maximum possible speed, it's finding that sweet spot. Sustainable power that works with the chassis.
Precisely. And the sources highlight 3 specific 550 motor options that fit different driving styles within that reasonable zone.
Okay, let's break those down. What's the top recommendation, the sort of best all-arounder?
That seems to be the Red Cat Racing 19T 550. It sits right in that Goldilocks zone. The feedback is really positive, gives a massive and immediately noticeable increase in both speed and torque over stock.
But without being so extreme that it just shreds the internals.
Exactly. It's powerful, makes the truck much more lively, but it's generally considered reliable and doesn't push the chassis components past their reasonable limits. It's described as the balanced performer, the reliable workhorse for this upgrade.
All right, Red Cat 19T for balance. But what if someone does want more speed? Like, for bashing around?
Then the next step up in aggression is the Traxxas Titan 12T 550. This is definitely the high-speed option among the recommendations.
12 turns, so significantly faster RPM than the 19T.
Yep. And a key feature of the Titan 12T is that it has an internal cooling fan built right into the motor.
Which it probably needs, running at that speed in this truck.
Absolutely. It's going to generate considerable heat due to the higher RPM and current draw. That fan is pretty much essential. But the sources also caution. This motor puts the most stress on the entire drivetrain. You're pushing the limits here.
Okay, so Titan 12T for speed demons, but be prepared for potential added wear and tear. What about the other end of the spectrum? If someone wants to use the 6WD for, like, slow, technical crawling.
For that, you look towards the Holmes Hobbies Trailmaster Sport 550. They offer it in different turn counts, but the recommendations are typically for the 21T or even the 27T version.
Higher turn, so lower speed, more torque.
Exactly. This motor completely changes the truck's character. It becomes an exceptionally capable trail rig. You get immense low-speed torque for climbing, and crucially, super smooth, precise throttle control for navigating tricky obstacles.
So you sacrifice top-end speed almost entirely.
Pretty much. But you gain incredible control. Plus, Holmes Hobbies motors are generally known for better construction quality. The Trailmaster Sport often has a ball bearing on the output shaft end, for instance, which reduces friction right at the motor.
Interesting. So 3 distinct options. Red Cat 19T for the best balance, Traxxas 12T for maximum speed with caveats, and Holmes Hobbies 2127T for dedicated crawling and control.
That sums it up well. And for that goal of system synergy and long-term fun, The Red Cat 19T really seems to be the sweet spot according to the consensus.
Okay, motor chosen, hardened pinion installed. We mentioned the motor bolts right in, but there's a critical setup step here, right? Getting the gears to mesh properly.
Oh, absolutely critical. You can have the best motor and the toughest pinion, but if you set the gear mesh incorrectly, you can ruin them, or the spur gear, very quickly.
That is gear mesh, exactly.
It's simply the spacing between the teeth of the pinion gear and the spur gear, how tightly they engage.
And what happens if it's wrong?
Two failure modes. If it's too tight, the gears are jammed together. You create a lot of friction and binding. This waste power makes the motor and ESC run hot, reduces runtime, and causes excessive wear.
Okay, too tight is bad. What about too loose?
If there's too much gap, the teeth don't engage fully across their surface. Under load, the force gets concentrated on the tips of the teeth, which can cause them to chip, deform, or strip completely, especially with the increased power of the 550 motor.
So how do you get it just right? There's a famous trick, isn't there?
Yep, the good old paper trick. It's simple, reliable, and works almost universally for RC cars.
Walk us through it. How does a piece of paper help?
Okay, you take a small strip of standard office paper, nothing too thick, just regular copier paper. You place it between the pinion gear teeth and the spur gear teeth.
Okay.
Then you physically push the motor towards the spur gear, so the paper is slightly squashed between them. While holding it firmly in place, you tighten down the motor mounting screws.
Right, locking the motor in that position.
Exactly. Then you simply rotate the spur gear slightly by hand, and the paper strip will feed out. Because the paper had a tiny bit of thickness, removing it leaves a very small, almost microscopic gap between the gear teeth.
Ah, so the paper creates the perfect amount of backlash, or play.
Precisely. You should be able to feel a tiny bit of movement if you gently rock the spur gear back and forth while holding the pinion still just a slight pick. That tiny gap is perfect mesh. Minimal friction, but full tooth engagement under power.
Simple, but sounds incredibly effective. Okay, pinion done, motor chosen and installed, mesh set perfectly. We're good to go.
Not quite.
Yeah.
The sources are very clear. Adding that 550 motors power fundamentally changes the demands on the rest of the system. There are 3 essential supporting modifications needed to handle that power and actually make the truck work well. These aren't really optional hop-ups. They're necessary for achieving that system synergy we talked about.
Okay, what's the first essential support mod?
Gotta kill the friction. The stock G6-01 kit comes with plastic bushings, or sometimes those porous bronze oilite bushings in the wheel hubs and gearbox.
And those create a lot of drag.
A ton of drag. They're basically converting your motor's power, your battery's energy, into useless heat through friction, especially with 6 wheels and all those internal gears spinning.
So the solution is?
A full set of ball bearings, sealed ball bearings. Mostly, the chassis uses the very common 1150 size, but you'll need a full kit specific to the G6-01 to get all the right sizes.
And swapping bushings for bearings.
Right.
What difference does that make?
Huge difference. Dramatically reduces friction. Everything spins more freely. This means higher top speed, quicker acceleration, longer battery run times because less energy is wasted, and your motor and ESC run cooler because they aren't fighting as much drag. Yeah. It lets the 550 motor actually deliver its potential.
Right, it unlocks the power you just installed. Okay, bearings are essential. What's next?
The power manager, the electronic speed controller, or ESC. The stock Tamiya unit, usually the TBLE's O2S, is a decent ESC for stock motors, but it's completely outgunned by a 550.
Why? What's the limitation?
It has a motor limit, usually stated in turns. The TBLE O2S is typically rated for down to a 23-turn motor. Our 550 recommendations are 12T, 19T, 21T, way below that limit.
And running a motor below the ESC's limit means?
It means the motor will try to draw way more electrical current than the ESC is designed to handle safely. It's like trying to run a massive industrial vacuum cleaner using the wiring for a tiny bedside lamp.
Okay, bad analogy potentially, but I get the idea. What happens to the ESC?
Best case scenario, it constantly overheats and triggers its thermal shutdown, so the truck just stops working until it cools down. Worst case, you permanently damage or destroy the ESC. Puffs of smoke, maybe?
Not good. So mandatory ESC upgrade. What kind are we looking for?
You need something robust with a much higher amperage rating. The go-to recommendation of the sources is the Hobby Wing Quick Run WP 1080.
Why that specific one?
It's known for being tough, waterproof, and it has a high continuous current rating, 80 amps. Plenty for these 550 motors. But crucially, for a heavy 6WD truck like the G6-01, it has a highly programmable drag brake.
Drag brake. What's that and why is it important here?
A drag brake automatically applies a certain amount of braking force whenever you let off the throttle. For a heavy truck, especially on hills, this is invaluable. It stops it from just rolling away freely downhill. You can set the strength of the drag brake on the 1080, allowing you to hold the truck steady on inclines or manage descent smoothly. Huge for control.
Ah, okay. Essential for trail driving or just managing the weight? So bearings, ESC. What's a third mandatory piece?
Handling. You've just given the truck significantly more speed and power. The stock suspension uses simple friction dampers.
Which are basically just springs with a bit of plastic rubbing inside a cylinder.
Yeah, pretty much. They offer very little actual damping or control. The result is a ride that's bouncy, uncontrolled, especially over bumps. At stock speeds, it's kind of quirky and fun, with 550 power.
It becomes borderline uncontrollable.
Exactly. The truck will bounce all over the place, tires lose contact with the ground, handling becomes unpredictable, and you can't actually use the speed effectively or safely.
So the fix is proper shock absorbers.
Proper oil-filled dampers, yes. You'll need 6 of them. The sources suggest Tamiya's own CVA plastic oil shocks, or maybe the aluminum damper set designed for the related GF-01 chassis, which also fits. You buy them in pairs, so you'd need 3 pairs.
And filling them with silicone shock oil provides real damping.
Correct. The oil moving through pistons inside the shock body provides smooth, consistent resistance to suspension movement. This keeps the tires planted, absorbs bumps properly, and gives you actual stability and control at higher speeds. It tames the beast, essentially.
Okay, that makes total sense. So let's recap the whole system. To really upgrade the G6-01 properly, you need Step 1, the hardened steel .6 mod 18T pinion. Step 2, a well-chosen 550 motor like the balanced Redcat 19T. Step 3, set the gear mesh perfectly using the paper trick. And Step 4, the mandatory supporting mods, a full ball bearing set, a capable ESC like the Hobbywing 1080, and 6 proper oil-filled dampers.
And that's the package. That's the system synergy. Do all that, and you don't just have a faster G6-01. You have one that's fundamentally more capable, significantly more durable, and honestly just immensely more fun to drive in whatever style you prefer.
It really transforms the truck. And thinking back to that stock pinion, that clever mechanical fuse, it does make you wonder, doesn't it?
How so?
Well, it raises an interesting question for you, the listener, to maybe think about next time you're planning upgrades. If Tamiya deliberately put that weak link in the G6-01 to protect the internals, what other seemingly weak parts on different RC chassis might also be intentional design choices? Little mechanical fuses hidden in plain sight, meant to protect more expensive or harder to replace components. And if you recognize those, how does that change your strategy when aiming for high performance?
That's a great thought to end on. Something to definitely keep in mind.